Hi, I'm Miss Hearn. Let's get started. In this video, we're going to find an equation of the line tangent to the curve y equals 2 plus 3x plus 10x times e to the x at the point where x is equal to 0. And then afterwards, we're going to use a graphing utility to graph the curve and the tangent line so we can just see what it is that we found. So some helpful facts that we're going to use in solving this problem is, first of all, that the derivative of a function is a formula for the slope of its tangent line. We're also going to use the product rule for derivatives. And the way I like to think of it is if you have a function that can be broken down into a first part times a second part, first function times a second function, then the derivative of that product is going to be the first function times the derivative of the second plus the second function times the derivative of the first. And then we have an e to the x inside of our function, so we're going to need to know that when you take the derivative of e to the x with respect to x, you just get e to the x back. It's kind of interesting that a function is its own slope. And then finally, we're going to need to know about how to write equations of lines. So one thing that you need to know is that when you want to write an equation of a line, all you need is the slope and a point. Now, of course, we're given that information in a variety of ways, but all we really need is a slope and a point. The slope part is where calculus comes in. We need the derivative. Y prime is going to be, well, the derivative of a constant term is just 0, plus the derivative of 3x is just 3, plus now we have this guy. So to find the derivative of 10x times e to the x, so that is something with an x times something with an x, we're going to think of our first part of that product as 10x and the second part as e to the x. We're going to need our derivatives of each of these pieces. So the derivative of the first part, 10x, is just 10. The derivative of the second part with respect to x is e to the x. So now we're going to follow the pattern first times derivative of the second plus second times derivative of the first. That's going to give us 10x times e to the x plus s, which is e to the x, times 10. The derivative of f, the first part. So our derivative can be written as 3 plus 10x e to the x plus 10 e to the x. So this is a formula for the slope of the tangent line at any point on the graph of the function y, but we want the derivative evaluated at the point where x is 0. We want the slope at 0. This is going to be our m in our equation of our tangent line. Plugging in 0, we have 3 plus 10 times 0 times e to the 0 plus 10 times e to the 0. Well, this term is just 0, and 10 times 1 is 10. So 3 plus 10 is 13. So our slope is 13. Now, we said that in order to write the equation of a line, we need the slope and we need a point. And we have our slope and we have the x value of our point. Let's find the y value by plugging into the original function. So if I take x equals 0 and I plug it into the function y equals 2 plus 3x plus 10x e to the x, this is not the derivative, it's the original function, then we would get y equals 2 plus 0 plus 0, or just 2. So our tangent line goes through the point 0, 2 and has a slope of 13. Well, not only is this a point, but because the x value is 0, that means that this is actually our y-intercept. So that makes writing the equation of the line particularly easy, because we can just say, well, the equation of the line fits y equals mx plus b, and we have m is 13 and we have b is 2. So let's go ahead and take the equation of this tangent line along with the equation of the original function, and we're going to graph it using a graphing utility. I'm going to use Desmos.com. So I'm going to give a little shout out to Desmos because they just do a great job on this website. I'm going to click Start Graphing, and we're going to plot the values that we need. So here I've plotted y equals 2 plus 3x plus 10x e to the x in red. I'm going to add to this the equation of the tangent line that we found, y equals 13x plus 2 in blue there. It's kind of hard to see because they bump into each other. I'm going to just zoom in a little bit. So here I'm going to plot the point 0, 2 so you can see the point of tangency there. And you see it should be that the blue line is very close to the red curve around the point 0, 2 because it's got the same slant as the graph at that specific point. And that's what we expect to see when we're looking at the tangent line most of the time. So I hope you found this video helpful. If you did, please remember to like it. That helps other students to find the video.